my name's Stephen Wisby from AWR Group. We're the representative for Samsung SDI in Australia for all of their energy storage systems, for the scalable and also the fixed battery unit, which is the smaller 3.6. What we're going to talk about today is the 7.2 and the 10.8, which is effectively the same machine. It just depends on how many batteries you put in it, and hence that's why it's the scalable. They are identified by serial number, saying that it's a 7.2 or a 10.8, but it really doesn't matter. If you've only got two batteries in there and you've got a bypass plug, which allows just the two batteries to work in series, the unit will automatically recognise it's 7.2, and by simply adding the other battery, will make it a 10.8. But just on that note, if you do have a unit that's 7.2 and you want to upgrade it, please consult us, because you do actually need to make sure that the batteries are balanced before you put them in. If they're too far out of balance, you'll get a lot of error codes and they won't rectify by themselves, and it will not operate because there is that imbalance there. So what you have to do is literally discharge or charge the machine up to whatever the voltage is of the battery you're trying to put in.
Adding it at a later date,
Yep.
does that restrict the life of the new battery to the old battery?
It does. The batteries are actually got a 10-year lifespan guaranteed by Samsung under their operating range. They're 6,000 cycles, which they estimate a cycle to be approximately 1.5 cycles per day. If you did 6,000 cycles, it works out to about 16 years if it was one cycle a day. But they say it's an average of about 1.5 cycles per day is to what you get out of the machine. So therefore, what they're effectively saying is a 10-year warranty on the actual, on the battery performance, and that's down to 80%.
Yep.
So when you're putting the batteries in, you simply just measure the voltage across the battery that you got. They do come at a 20% state of charge, but the most important thing is what voltage that is and what voltage your other batteries are at the time that you're trying to match them together. If you can get it within the 1 volt, then it will then balance from there. But if you try and put it in from one extreme to the other, as soon as you put it in, you'll, within a matter of minutes or even over hours and so on, you'll get a battery imbalance, and it can't rectify it, because what it's trying to do, it sees all cells collectively. In fact, it actually reads every single cell in the battery. So it's trying to make sure that it's maintaining an equal charge between a lot of them. Because they're electrically connected, it should do that, unless of course one cell was faulty. But if you go and force a whole tray in there that's way out of voltage range, it's only the one amount of charge that's going through all 3 batteries, or all 2 batteries, whatever. So therefore, it can't get that balance, and therefore it'll have an out of voltage range.
And then what, do you just do equalisation like manually on it, or what?
Yeah, if you're on site, like when we're in the workshop, we can actually just charge or discharge the battery to match what's in the machine. But if you're going to get delivered a machine out on site, and we're asking you over the phone, because you guys can ring us at any time and we'll give you assistance. We'll send you a battery, or you would have bought a battery, from your distributor. You would have taken it out on site, and you would have taken out the jumper bar, which we'll have a look at later. And the jumper bar, all 3 batteries actually go in series with each other, so the voltages just increase.
That's what my question was. So that's why you can't increase the state of charge, because it's a single current flow.
It's just in series. So what you're doing is, when you've only got 2 batteries, you're actually putting in a jumper ring. Now, it's not just a shorting bar. They call it a shorting bar, but it's actually got battery tray testing. So it'll actually do reference to your cell voltages and to your temperature and all that. So they've got jumpers in them as well. So it then allows the circuit still to flow without having a battery in the circuit. The voltage then will drop. The machine automatically knows what voltage it is and what range of batteries you've got to utilise. And it does everything from there. You don't need to program anything.
Yeah.
The rule of thumb would be to have everything fully charged.
Well, as I said, you're going to get that. You're going to get that spare battery off the shelf at 20%. That's how it comes from the manufacturer.
You could
Yeah,
charge
you
it
don't know
before
what
you
your
take
customer's
it out.
going to do, do you? So-
Sorry.
You could charge it before you take it out the site.
How are you going to do that?
Oh, I don't know. Can't you just charge it? You get a charger and charge.
But you don't know what your customer's battery state of charge is going to be.
You
when you
have
get
no
there.
idea. So the whole
so-
point is
Oh, okay.
that would be irrelevant. You've got to match it within a volt.
Yeah, no, that's
so
fine.
therefore, you've got to do it out on site.
Yeah, yeah.
As I said, when we're in the workshop, we have the luxury of just measuring the voltage in the machine without having to charge or discharge the machine, which you can do as the installer, which we'll also have a look later, and then match it to what you've already got. And then you can simply put it in. But when you're out on site, you have to do it the other way around. You actually have to measure the voltage of the battery that you're putting in,
One. Yeah.
and therefore adjust the charge up and down on the machine itself.
Yeah, that's right.
So is there a minimum state of health that you'd, like if you state of health, the original batteries at a certain point, you wouldn't add a new one to it?
It'll only ever bring everything down to the lowest point. The machine actually tells you what state of health your batteries are, so it actually has your SOH on there. Obviously they start at 100 and they'll decline in time, but by putting in another battery, what you're effectively doing is instantly driving that other battery down to whatever level the other ones are. But again, within the next 10 years, it still should be within a manufacturer's tolerance range anyway. So that shouldn't really, it should be,
If they're in
it's not as if
series.
it's going to be 50% or something like that. If they're in series, you're always going to be driving that other battery. You're going to be driving the other batteries hard, and the other one you won't be driving it as much because it'll have a better state of health.
Yeah, but so the state of health is going to be based on the worst.
On the worst condition of the battery that's in the system because they're in series, yes.
So Steve, just before you move off that point, if I could, you were saying if you've got one that comes factory default charge at 20%,
Yep.
and say you arrive at site to upgrade your client's system and they're at 80 or 90%,
Yep.
can you pull the other two batteries out, bang in the single one, they then come up to the same charge?
You need two batteries to run the
Need two.
unit at any one time. So it's a two-thirds.
Single discharge.
You don't have an option with one, and that's the problem with the scalable and trying to do it that way. You simply have to match those two batteries that are in there to whatever the voltage is of the battery you're going to put in. And as I said, you as the installer can charge and discharge the unit without putting any external loads on there. Actually plug your computer in, go into the back end of it, which we can actually do. And then actually just go charge. You can actually do it remotely as well. So you can actually do a charge and discharge as a test on the other side of the world.
So how long does that take to discharge down to 20% from?
Does it a
90%?
1 kilowatt? Does a 1 kilowatt charge or discharge from the grid or from an internal load? And therefore, whatever kilowatt hours it takes to get it down accordingly. 7.2s.
Is that 1 kilowatt per hour?
Yeah. The 7.2 under normal operation.
Sell it!
Under normal operation can actually run at 4 kilowatts charge and discharge. The 10.8 can actually do it at 4.98, so 5 kilowatts, which is the maximum of the inverter. On a side note, every battery tray, you've got 3.6 kilowatts per battery tray. So it actually has two batteries on that tray, but without getting confused, you have up to three battery trays can go into the unit. Each battery tray is 3.6 each. So you've got 3.6, 7.2, which is the minimum for the scalable, and then you've got 10.8. Now, in the whole range of machines, the 3.6, which fits into the smaller unit, the 3.6 kilowatt non-scalable, that has a maximum charge-discharge of 2 kilowatts. So for every tray, you get 2 kilowatts of power to charge and discharge with. So if you've got the 7.2 in there, the maximum that you can get out of the batteries when it's in backup mode, for example, is 2 kilowatts out of the batteries going through the 5 kilowatt inverter. You've still got optimum up to 5 kilowatts in assistance with the solar as well, so that can then top it up. But purely out of the batteries, maximum 4 kilowatts, 2 lots of 2, and then the third battery tray theoretically would be 6, but it can't because it's limited by the 5 kilowatt inverter. So therefore you've got a maximum of 5 kilowatts in off-grid or in backup mode. when it's in grid mode, so you've got assistance from the grid as well. So what this unit does, it has solar. The solar actually is the primary source to power up this unit. If it's in an off-grid environment, the unit will not start up in battery mode. It has to start up from the solar each morning. So if you're in an off-grid environment, without the grid at all, the solar will charge the batteries or provide to the load. It will determine what's best and efficient. If the battery is dead flat, it can only start up in solar mode, and it will charge up to about 20% before it will provide to the load, just to give those batteries enough kick to then move on the rest of the day. Usually by that stage in perfect weather, the battery's well and truly on its way to be charged anyway, and you've most probably within the first hour and a half or 2 hours, you've pretty much got quite a bit of kilowatts available from the sun and from the batteries to provide to the load anyway. Batteries take about 2 to 3 hours to fully charge, depending on if there's 2 or 3 batteries with good irradiance available. And so therefore, if on a good day, you could be fully charged by 8, 9 o'clock, even 10 o'clock in the morning at the latest, and be fully charged for the rest of the day, your load's being provided for by, if you've got enough PV, by the PV alone, and therefore at the night time, you've got a fully charged bank of batteries to continue on of the rest of the night. A lot of the off-grids are actually working quite efficiently, running their dwelling just purely on that battery and charge situation, getting full 24 hours out of it. Some of them are borderline. Every single installation is going to be different, depending on their load usage, depending on the weather. As to whether or not the battery also assists to the load during the daytime when the clouds are up and down. So that's the other thing the customer's got to be aware of, that the battery's always assisting to the load. The main aim of the machine is to minimise the grid input, or in an off-grid situation is to at least maximise, keep them up to the load.
So can you set it though to say don't use any battery, just use grid?
Not at this point in time. What they come up with down the track. Right at the moment, we'll only discuss what it can and can't do, but they're always developing different requests all the time. That's been pretty much a major request from day one. Some customers just want to use their solar without any use of battery and get the optimum out of it when they come home at, say, 6 o'clock at night to get the best out of their batteries. On a day like this, where it's quite cloudy and everything else, you might find that the battery use, there's not enough solar charge to the battery in the first place, which is the most important thing about the initial installation. This unit can take 2 lots of 3.3 kilowatts of power on each string. If you provide that to the unit, you're going to get the best performance out of the battery charge and the battery performance, and also providing to the load directly from the solar. If you have somewhat less solar, you're going to not give the best value to the charge of the battery. It'll work perfectly fine on a perfect day. On the not so perfect days, your performance will drop by the amount of panels you don't have. So if you can put the premium amount of panels on the roof, which is a total of 6.6 kilowatts, you're doing best justice to the customer and the performance of the machine. And you'll notice massive differences. We've got 2 operating at work. One's on 2 lots of 2 kilowatts and one's on 2 lots of 3.4 kilowatts of panel power. And on an average day, we really notice the difference between how much the battery charges to and what we've got left at the end of the day, compared to the other one, which was always topping up the battery and always providing to the load. And the difference was, just the inclement weather just giving us that, not giving the best performance to charging the battery at the very least. It's still operating quite well.
That's one of my hardest thing I've found to understand is, and I'm sure everybody or other people have it too, is that we've got to remember that when the solar is producing power, you're using that power. You've got to get it in your mind, and so therefore you're not flattening the battery, and that if there's enough energy coming from the solar, you're using that first.
The unit has
Yeah.
priority to charge the batteries. Its main priority is to charge the batteries, but it always takes into consideration the load. It's not black and white as to what it does. If the batteries are so flat that it simply can't provide to it, if, say, it's a really poor day, your batteries are flat when you wake up, you're on the grid, you'll find that the solar, whatever solar's there, will just go straight to the load. Because if it considers that it's under a certain rate that it has no chance to share, it will take a choice of load. But its main priority is to charge the battery. That's when you've got the grid. It's slightly different when you've actually got off-grid, you don't have a choice. So therefore, its main priority is to charge the battery, and whatever's left will go to the load. Doesn't mean that it will cut out. It will, if someone plugged in something, it will simply mean that it will give less charge to the battery because the solar will go to the load. But over a period of time, its main aim is to charge the battery first, provide to the load, and overall give you an efficiency factor. Now, the good thing about the Samsung is that not only is it an efficiency thing where you've got solar and you've got battery contributing to the load, but you've also got this off-grid circuit as well. You've got this backup circuit that if the grid goes off, it will disconnect internally and it will simply provide solar and battery just simply going to that emergency circuit. Now, this emergency circuit, what we're going to discuss is the main thing that we're going to discuss of how to wire it up. It's not hard. All you've got to keep in mind is that the emergency circuit is the load either pointing to the grid or either pointing to the output of the ESS. But never should they be seen to be able to do both. That's why we've got to change that switch to allow it to either, if you've got a grid going to the load, what you've done is literally taken that whole active circuit out, put it into the back of the bypass switch, the entire load that you want to run off that machine, and therefore that's going to be your pivot point between either pointing back to the grid and simply bypassing the ESS unit altogether, and therefore providing the circuit as normal, or pointing that load to the output of the ESS, which then means that whatever's going through the ESS, whether it's grid through the ESS to that load, or it's in backup mode, which means battery and solar only are providing to that load, then it's only got one path to get to that load. You can have other loads around it. You can have air conditioners or larger loads that you might not normally want to put onto the unit. They can be separate to the unit and they can be run together. The new version 2s actually allow, when it first came out, it was actually non-compliant in the very early days where it was, Samsung were trying to design it like they did in Europe, and they don't have MEN in Europe. And therefore what they were trying to do is have a floating circuit on the output. Don't have that issue anymore. They've redesigned it, and we now have where you've got your common neutral. So it's all MEN connected. All you're doing is pointing the active of that load either back into the ESS or back to the grid. Okay, you've all got your diagrams and everything there. Before you go, I will get you to fill out the form just to tick the boxes so we can get all your details, and we'll send a certificate that you've done the course. The other information is on the diagram. Now, we're in the process of actually getting the diagram redone, just to show emphatically that the neutral is actually bonded in all aspects to the MEN, and it doesn't matter that you do it that way, and therefore it actually gives you a few options as to how to wire your active and neutral to the bypass switch, which we'll have a look at in just a moment. I've got another one of those. I'll look up here. It's okay.
Steve, is there any default where the battery's down that low that will charge from the grid first?
Batteries don't. The batteries do not charge from the grid as under a normal situation. You can charge the batteries from the grid as an installer to actually check that the batteries are charging and do discharging and so on. The only way that you'll be able to do that will be the likes of Reposit Power, which they'll then, if you've got a Reposit box, they'll actually command the Samsung like they do with the Teslas and others, and it will determine the customer's use on what is best for them, their best It'll remember their time of use and what they're doing over a period of time, and it will learn your system and your house, and it will start then determining between weather, which the Samsung can already do, but we actually turn the weather feature off at the moment. Because it will automate into charging of a night time when some customers don't want to charge from the grid. They want to have the opportunity of just using the solar and the battery under their low load and not have to draw from the grid at all. And the system does that quite efficiently. If you tell it that there's different time of use, it will then determine that there's a cheaper time. If the weather, it has a weather forecast on here. If the weather is inclement, it will charge if the batteries are flat early in the morning in an off-peak, in a low charge situation. So to avoid that, we just leave all the values at zero. What the recorder does is it will learn in time smartly, and it will actually pre-charge the battery and make sure it's fully charged when you wake up in the morning, because some people might be using their battery all the time and therefore wake up in the morning and all they're doing is using the grid in a shoulder situation, whereas if they charge it in off-peak, then they're getting best value with a fully charged battery, providing for that load when before the sun's really up. So that's the sort of thing that those sort of boxes are doing, and making these units even smarter. But they handle it quite well, just depending on what sort of load you're putting on. So,
but is the customer going to be consulted about that so that he can decide whether he wants to use solar or say Energex power? Or does it do it automatically?
No, it doesn't. Its main aim. The main aim of the Samsung as a standalone is to give the customer the most efficient experience of not using the grid. The main aim is to use the solar first, battery second, to provide to the load, so you're not using any grid at all. And we've been in situations throughout the day at work, we've used something like 25 to 30 kilowatts of power at work and only utilised about 400 watts of power out of the grid. So the consumption from the grid is quite efficient, showing you that it's not zero, but at the same time it's a lot better than 25 or 30 kilowatts. So, and again, all that depends on the condition of the batteries, what sort of load you're putting on there. If you go above the 5 kilowatts and just want to use 7 or 8 kilowatts, which you can do on a pass-through of the unit, obviously you can't provide battery and solar to that. You will have that difference of grid power. But if the 5 kilowatts is quite a large amount for a normal household, so if the customer's wise in the way that they use their power, or even in an off-grid situation, which they're usually wiser, then these units will perform fantastic.
What is
actually get through
pass-through
24 hours
current?
without. Sorry.
What's pass-through current? Like what can you?
You've got in grid mode, you've got up to 38 amps, I think it is, or 35 amps. So that's about 8 kilowatts of power. That's grid power pass-through, and that's with assistance of the 5 kilowatts. So the system has a limitation up to that 35 amp mark, or 8 kilowatts. In backup mode, it's only 22 amps, which is 5 kilowatts at 230 volts. So the limitation is on the inverter when you're in backup mode, but there is a pass-through current limitation if you're designing it within a house, and that's why I said you do need to have some circuits considered for outside of that, especially we've noticed some hand tools like electric saws and that, they have really high spike currents. If it's in backup mode, the units don't tend to like that. If it's an extremely high current draw, instantaneous, it'll make it go into a warning mode and actually trip the unit off, and then the unit will come back on again.
So there's no ratings for that? The continuous, like SMA's electronic will give you 30 minute, 30 seconds continuous ratings?
Well, it goes up to the 35 amps, but these things, if you're doing current draws of whatever, could be 50, 60, 80 amps or something, just as a spike. If you're doing extremely high spikes, it may trip it out. We've noticed it with some cheap electronic tools, like we've got one circular saw at work that does it, but there's nothing else. We've got really very large loads of fluorescent lights and other things that we turn on that sit there, you know, groaning as you're turning it on. The unit handles it fine. So it really comes down to specific tools, which I couldn't give you a list of because it's only from our experience that we're learning what it can and can't do. And on this case, it's only the one device that we've noticed, but just to be fair, that type of thing obviously has done, has caused it to maybe trip off. But other than that, you can have your pass-through circuits. You can also have external smart meters. They have an internal smart meter for the pass-through circuit. You can actually put an external smart meter on, and it can actually make it see all loads. So what that will do is then give out the battery power back out the front end of the unit as if it's going to the grid, but it knows that there's a load somewhere in your house because that's the smart meters at the front of the board, and therefore it will then go to that load. So you
So is it just a CT or is it?
It's a Carlo Gavazzi three-phase meter, so you can put three-phase or single-phase, and actually let the single-phase unit see across 3 phases or other circuits. So it captures the entire load of the house rather than just any limitation you put through. Some people actually wire up the whole house through the unit, and then the customers just may, you know, advise that don't turn everything on syndrome. But it depends on how big the house is, and it's up to you guys to advise the customer that there is a limitation, but for convenience sake you might want to put the entire house through the circuit and therefore not have to split the circuits up.
What about export limiting? Can you change that?
Yeah, you're talking about your feeding
Yeah.
back to the grid.
Yeah.
You've got between 100% feeding back to the grid all the way down to 0 in 1% increments.
Okay.
Like anything that you want down to 0, and 0 should then not feed anything back to the grid. So therefore it will then limit the inverter or the PCS, the power control system, from actually exporting excess power. So priority will be solar to the load, battery to the load, or battery charge. Everything will go to that, but the front end will not feed into the grid, or it will feed in a percentage of whatever the inverter power is.
Yeah.
So very good for Queensland. Okay, as it says, we've got 6,000 cycles that the batteries are rated for, and that's up to 80% of the capacity of the battery. Now the batteries charge on a daily basis from 5% to 95%, so they have a total of 90% depth of discharge at any time. So the two extremes are always the reserves of the battery. So the experience for the customer will be that it will not discharge any flatter than 5%, thereabouts, give or take 1%, and it will not charge any more than 95%.
Can you vary that?
No.
So you can't say only go to 60%.
No.
So just something you have to make the customer aware of if they're looking at their monitoring, they're seeing 95% as the maximum
That's
state
the
of charge of
maximum.
the battery. So
That's correct.
you're not going to see 100, it's always 95.
Correct. I think some of the other battery manufacturers, I know there's a couple around that actually do the experience of 100, 0 to 100.
It probably saves your customer querying
And,
things.
look,
Just fudge it behind the
it's
scenes.
something that we've mentioned to Samsung. They're doing it from a practical situation, and it's the way that I would say most batteries operate, is that they always have that reserve, but some of the manufacturers hide that range. And as you said, the customer's the one that has the experience of saying, can't get any more than 95% out of it, and it won't go flat. So it is. It's going flat to what it's been set for, and that allows you to get the longevity out of the battery over those over the period of time. Okay, so the difference between we've got the 3.6, which is one battery tray. That's a smaller unit that Samsung no longer sell in Australia. They've actually decided just to fully focus on the larger units, and it's most probably more practical that they do. The other one's a token for people that want to get into the market, and they most probably did have a very good practical use under small situations, but then it was a cost factor. So, you know, the cost of buying this compared to buying this with, you know, 3 times the amount of battery power is now the factor that they're looking at.
They're not going to sell it without batteries?
No, it'll always